Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge IGCSE Physics. This is the extended physics. Today we have set our hearts to solve a paper 2 of this subject. And we have selected October-November 2022 2-3 paper. This paper 2 belongs from the zone 3. This is a multiple choice paper. So the time allowed for this paper is 45 minutes. And the total marks for this paper are 40. The value of the G in this paper we are going to take as 10 Newton per kg, or you can say 10 meter per second square, the G value. But in the latest papers, the papers which started from 2023, we take the G value as 9.8 Newton per kg, or you can say 9.8 meter per second square. In this video, I am going to present you the solution of this paper to the best of my abilities and to the best of my knowledge and skills. So let's hope you will be able to understand this paper. So let's start. So this is October-November 2022 2-3 paper. So let's start. Here we go. The question number 1 is coming up on your screen. A wire is approximately 48 centimeter long and has an approximate diameter of 0.3 millimeter. Which measuring instrument can be used to obtain more precise values for the dimensions of the wire? Because the length is 48 centimeter, we will be using ruler. 30 centimeter ruler, so the length is larger than this. Half meter rule, okay, this can be used. For the length, we will use the half meter rule. Half meter rule is 50 centimeter long. And for the diameter of the wire, we use a micrometer. So I think C looks the best answer to me. Question number 1, and the C is the answer, sir. Okay, so the next question coming up on your screen, question number 2. He says the velocity and velocity time graph. Okay, the velocity time graph for a car is shown. So on the y-axis, the velocity is shown, and on the x-axis, the time is shown. What is the distance traveled by the car in 35 seconds? So, the area under the speed time graph, that is equals to the distance traveled. So I can find the area under the speed time graph. For this purpose, I will divide the area under the speed time graph into 3 portions. And I will find the area of each portion, and then I will find the sum of those areas. So let me say this is my area 1, and this is my area 2, and this is my area 3. Area 1 is a triangle, area 2 is a rectangle, and the area 3 is a trapezium. The rectangle's area is 1 by 2 into base into the height. The rectangle's area is length into width. And the trapezium, its area is 1 by 2 into the height into the sum of the parallel sides. So I can find out the distance traveled very easily. So here we go. So this is, sorry. Question number 1 was supposed to be here. Okay. Now we have the question number 1 coming up on your screen. The solution, it will be 1 by 2 into 10 into 10. That's the triangle, plus 10 into 15. That's the rectangle's area. And 1 by 2 into 10 into the 10 plus 20. So it will be 50 plus 150 plus 150, and that will be 350 meter. 350 meter, 350 meter, 350 meter is this. B is the answer, sir. So let's check question number 2. B is the right answer. This is how we have done this. I hope you understand. Question number 3. Which property of a body results from the effect of a gravitational field on its mass? That is the weight of the body. You know, the body who has mass, when it is in the gravitational field, due to the gravitational field, it will experience weight. For example, if we talk about the Earth, a body who has mass, the Earth will attract it towards its center. So that will cause the weight. So that is the weight of the body. Which property of a body results from the effect of a gravitational field on its mass? That is the weight of the body. So I think question number 3, D is the answer, sir, and D is the right answer. I hope you understand. Next, question number, this is question number 4, and he says, okay, he says the diagram shows 4 pieces of laboratory apparatus. We have balance, we have measuring cylinder, ruler, stopwatch. Which pieces of apparatus are used to find the density of a liquid? If you want to find the density of the liquid, we need to know the mass of the liquid and we need to know the volume of the liquid. The mass of the liquid can be measured with the help of the balance, and the volume can be measured with the help of a measuring cylinder. So I will need these two instruments, measuring cylinder and the balance. So balance and the measuring cylinder, B looks the right answer to me, sir. Question number 4, B is the right answer. Question number 4, B is the answer. Okay, so we are on the question number 5, and he says, a metal rod of the length 80 centimeter is pivoted at the point O. So this is your pivot, okay? Its center of mass is at midpoint, and 4 pulley wheels are indicated by the letter P. Okay, so here we have a pulley, and here we have a string. This string is tied with this ruler here. And here we have a mass hanging with this thread, which is of 0.1 kg. So I will find the weight of this, and how you find the weight of this. The weight will be equals to the weight of this mass will be W is equals to mg. The mass is 0.1, the G value is 10 Newton per kg. So there will be a force of 1 Newton here. So this is going down with the force of 1 Newton. So this is going down with the force of 1 Newton. Same force is acting here in the upward direction. So this will be 1 Newton force. The same thing is happening here. So this is trying to pull it downward. So here we will have a force acting on it, which will be 1 Newton. And it will be acting in the upward direction. So at this point, a force of 1 Newton is acting upward. At this point, there is a force of 1 Newton acting upward. Approximately here somewhere is the weight of this rod, which is questioned to us, and that is acting downward. This force here, 1 Newton force, that is trying to produce anti-clockwise moment. This force is also trying to produce anti-clockwise moment about the O. And the weight of this rod here, which is at the center of the rod, this rod is 80 centimeter. So this is trying to produce clockwise moment about O. So we can find this W value, very simple. Let me show you. Okay, so here I have tried to, okay. So the weight of that weight of that thing which was hanging there, and that is 1 Newton. So I have tried to make that diagram a little simpler. This F1 is trying to produce anti-clockwise moment about O. This F2 is also trying to produce anti-clockwise moment about O. This weight of the rod is trying to produce clockwise moment about O. The moment arm for the F1 is 20 centimeter. The moment arm of the F2 is 60 centimeter. And the moment arm of the weight of the rod, that will be 40 centimeter. According to the principle of moments, the clockwise moment is equal to the anti-clockwise moment. So W multiply 0.4 is equals to 1 multiply 0.2 and 1 multiply 0.6. I have taken the lengths in meters. So 0.4 W will be equal to 0.8 and W will be equal to 0.8 divided by 0.4 and the weight of that rod will be 2 Newton. The weight of that rod will be 2 Newton. So that means the C is the option. Let's check. So question number 5, C is the right option, sir. This is how we have solved it. I hope you understand this. This is a little tricky question. Question number 6. The diagram shows an object moving at constant speed in a circular path in the direction shown. A force acts on the object to keep it in the circular path. In which labeled direction does this force act when the object is in the position shown? Whenever you move in a circular track, your speed might be constant, but there is a resultant force which is changing the direction of the velocity. And that resultant force is always directed towards the center of that circle. The acceleration of the body is also towards the center of the circle. So I think the direction of that force will be D. Question number 6. D is the right answer, sir. Question number 7. A force acts on a body of mass m for a time t. During this time, the velocity of the body increases from u to v. Which equation relates F, M, T, U, and V? This term impulse. Impulse is equals to force multiplied time, and impulse is also equals to change in the momentum. The impulse is force multiplied time, and the change in the momentum will be mv minus mu. So here we have. So F into T is equal to mv minus mu. You can take that m common. So impulse is the product of force and time, and impulse is also change in the momentum. Take m common. So F into T is equal to m bracket start v minus u bracket close. So I think C is the right option. Question number 7. C is the right option. Question number 7, C is the right option. Question 8. An object falls towards the Earth's surface. What happens to the gravitational potential energy and to the kinetic energy of the object? As the object is falling down, its height from the surface of the Earth is decreasing, so its gravitational potential energy is decreasing. But as you fall down, the speed of the object increases. So we can say, as you fall down, the gravitational potential energy is decreasing and the kinetic energy is increasing. Gravitational potential energy is decreasing and the kinetic energy is increasing, sorry, as you are speeding up. So I think B is the choice. Question number 8, B is the right choice. Question number 9. A skier is pulled up a short straight slope at constant speed by a rope. The tension in the rope is 10 Newton and there is a combined frictional and air resistance force of 220 Newton acting on the skier. The slope is 10 meter long and the skier rises 1.5 meter vertically. How much work is done by the rope pulling the skier up the slope? You see, we can find the work done. There are two methods. If you know the force which is pulling it up, and that force multiplies the distance traveled in the direction of that force. This is one method. The other method is the gain, the work done is equals to the gain in the gravitational potential energy. For that, we need the vertical height gain that is given 1.5 meter, but we do not know the weight or the mass of the body. So I cannot go after that formula where the work done is equals to the gain in the gravitational potential energy. So I have to go with that other formula, which is that the work done is equals to the force multiply the distance traveled in the direction of the force. Because the tension in the rope is is pulling that body up that slope. So I can say use that force which was in the rope as tension, and multiply it with the body moved in the direction of that tension. Okay, so the force which is in that rope is 100 Newton, and it is pulling that boy upward. So the work done will be force multiplied the distance traveled in the direction of the force, that is 100 multiplied 10, that is 1000 joule. 1000 joule. I think C is the answer. This is a little tricky question, number 9C, and this is the calculation. Here, this question is little tricky because there can be 2 or 3 situations by which we can calculate the work done. And the tension is in the string is the force which is pulling that boy upward on that slope, along that slope, you can say. Question number 10. In some situations, a force does work. Which set of conditions increase the quantity of the work done by the force? So when you increase the force, obviously the work done will increase. You know the work done is force multiplied the distance traveled in the direction of the force. So if you will increase the magnitude of the force, the work done will increase. And if the body moves more distance in the direction of the force, and even then the work done also increases. So increase the magnitude of the force and also increase the distance moved by the body in the direction of the force. So CC, distance moved by the force, that they both should increase. Question number 10, I think C is the answer, sir. That's the right answer. Distance moved by the force. Measuring cylinder, this is question number 11. A measuring cylinder of cross-sectional area 4 centimeters square contains 224 cubic centimeter of liquid. The pressure of the liquid at the base of the measuring cylinder due to the liquid is 8800 Pascal. What is the density of the liquid? You know the density, the pressure due to a liquid, we can find out. The formula is very simple. The pressure is equal to rho GH. I need to find out the H. So if you know the volume and you know the cross-sectional area, you can find out the, if you know the volume, you know the cross-sectional area, you can find the depth of that liquid in that tube. So 224 equals to 4 multiply H. That's the formula for the volume. Volume is equals to the cross-sectional area multiply the length of that liquid. So H will be equals to 224 divided by 4, that is 56 centimeter. So in meters, it will be, to convert centimeters into meter, you divide it with 100. So it will become 0.56 meters. So the depth of the liquid is 0.56 meter. You know the pressure of the liquid is rho GH. So 8800 is equals to rho multiplied 10 multiplied 0.56. So the rho, which means the density of the liquid, that will be equals to 8800 divided by 5.6, and that will be 1571.4, which is, when you round it off into two significant figures, it will be 1600 kg per meter cube. 1600 kg per meter cube. So that is the answer C. Question number 11. C is the answer, sir. This is how we have solved it. I hope you understand this and you understand this calculation. So question number 11, C is the choice. So here we have question number 12. He says the pressure of a fixed mass of a gas in a cylinder is measured. So we're talking about gas, its mass is fixed. The volume of the gas in the cylinder is slowly decreasing. So we are decreasing the volume of the gas. We are trying to compress it. The temperature of the gas does not change. So the temperature of the gas is not changing. So that means the temperature does not change. So, when the temperature does not change, when you will decrease the volume, the pressure will increase, because the pressure and the volume of a gas when the temperature is kept constant are inversely proportional to each other. So when you decrease the volume, the pressure will gradually increase. So they say which graph shows how the pressure of the gas changes during this process. Okay, so let me reduce the size so you can see the whole thing together. Okay, now as the time is passing by, you are decreasing the volume, which means you are increasing the pressure of the gas. The pressure of the gas obviously will increase. But remember one thing, when the time was zero, the gas has certain pressure. The pressure was not zero when the time was zero. So C is the answer, sir. Okay. So as the time is passing by, when the time was zero, the pressure was not zero. But as the time is passing by, the volume is decreasing, the temperature is constant, the pressure of the gas is increasing. So C looks the best option to me. Okay, the C looks the best option to me for question number 12. Okay, so C, question number 12, C is the right answer, sir. Hope you understand. Okay, so we are on the question number 13. He says, which statement about evaporation is correct? A body in contact with an evaporating liquid loses thermal energy. Yeah. A decrease in the surface area of an evaporating liquid increase the rate of evaporation? No. If the surface area will decrease, the rate of evaporation will also decrease. A wind over a liquid decreases the rate of evaporation. That is wrong. The wind over the liquid surface will increase the rate of evaporation. It is necessary to provide an external source of thermal energy to a liquid for it to evaporate. That's not right. The liquid, its molecule is on their own energy evaporate. Okay, so I think A is the best statement. Question number 13, A is the right answer, sir. Question number 14. Which change in the design of a liquid in glass thermometer makes it more sensitive? A larger liquid reservoir. A larger liquid reservoir means that it will have more amount of the liquid in that reservoir. The more the amount of the liquid, the more that liquid will expand. Less the amount of liquid, there will be less expansion in that liquid for the change in temperature. A longer tube, that's not right. A smaller liquid reservoir means a small amount of liquid, which means that less expansion, which will not make it sensitive, more sensitive, I mean. A smaller liquid reservoir, a wider tubes make it less sensitive. So a larger liquid reservoir. Sensitive means for 1 degree rise, how much is the change in the length of the mercury column? So more the change in the length of the mercury column for every 1 degree rise in the temperature, that is more sensitive. So the more it makes it more sensitive. Question number 14. We think A is the answer. A is the right answer, sir. Question number 15. An ice cube of mass 12 gram at 0 degree centigrade absorbs thermal energy from the surroundings at a rate of 3 joules per second. The specific latent heat of fusion of ice is 330 joules per gram. How long will it take for the ice cube to melt? Okay, so the mass is given here, the mass of the ice which is to be melted. Okay, this is the power given, and this is the latent heat of fusion given. Okay, so we will, with the help of the latent heat and the mass given, we can find out how much heat is needed. And then with the help of the power, I can calculate how much time it will take. So let me show you. So the heat needed to melt 12 gram of the ice will be heat is equal to ml. So heat will be 12 multiplied 330, and that will be 3960 joules. You know the power is equals to heat divided by time. So time will be equals to the heat divided by power. So time will be equals to 3960 joule divided by 3 joules per second. So that will be 1320 seconds, 1320 seconds. So 1320 seconds. So I think B is the option, sir. Question number 15, B is the right option. This is how we have solved it. I hope you understand. 15B is the answer, sir. So the next question on your screen is question number 16. He says, which piece of equipment is designed to produce a type of electromagnetic wave? You see, when we have electric fire, that gives out infrared rays. So that is electromagnetic wave. And electric generator do not produce this. Electric motor do not produce any kind of electromagnetic wave. And the electromagnet also do not produce any kind of electromagnetic wave. So only the A, when there is an electric fire, for example, electric heater, it gives out infrared rays, which are electromagnetic wave. So question number 16, A is the choice. Question number 16, A is the right choice, sir. Then we have question number 17. A passing boat causes a floating object to on a lake to bob up and down 18 times in 12 seconds. So from here, I can find out the frequency. The frequency will be 18 divided by 12. The wavelength of the wave created by the boat is 48 centimeter. We know the wavelength, we know the lambda value. What is the velocity of these water waves? So I'm going to use the wave equation, which is V equals to F lambda. So I can find the velocity. Okay, the frequency will be 18 divided by 12, and that will be 1.5 hertz. Lambda, which means the wavelength that is given, it is 48 centimeter. We know V is equals to F lambda, so V will be equals to 1.5 multiply 48. So the answer will be 72 centimeter per second. 72 centimeter per second. 72 centimeter per second. So I think question number 17, B is the answer, sir. Question number 17, B is the right answer, sir. This is how we have done it. And question number 18. Wavefronts are incident on a boundary. What is needed for the waves to refract at the boundary? You see, the waves will refract if their speed will change. If their speed changes, then the waves will refract. A shiny surface at the boundary, no. A small gap in the boundary, no. A different medium either side of the boundary in which the frequency of the wave is different, the wave frequency do not change. The different mediums either side of the boundary in which the speed of the wave is different. The waves refract when their speed changes, when they are entering from one medium into the other medium. So the speed must change. So I think D is the answer. So it's a fact, famous fact. Question number 18, D is the answer, sir. Question number 18, and we have marked also. Yeah. A person uses a magnifying glass to look at a stamp. Which ray diagram shows a thin converging lens being used to do this? Okay. The magnifying glass is a convex lens, which means converging lens. And the object is placed, the stamp is placed inside the focal length. And then the virtual and magnified image of that stamp will be formed. So if you prolong this line, which is passing through the optical center, it's not deviating. So if you prolong it behind, okay, and if you prolong this line, which after passing through the lens is passing through this F, which is the focal point, and when you prolong it behind, you see, so here somewhere they will intersect, here the image will be formed, and that image will be virtual and magnified. So I think A is the right answer, sir. And the rest of the answers, they are not right, you see. Here you can see the object. This, how do I know? You know, this is the F. Here, this is the F focal length. And this object is more than F. So when you prolong them, these lines intersect here. So this is a real image. So this is not magnifying glass. Here, these lines will intersect here somewhere. So they will make a real image. And this is totally wrong because this line is diverging, which do not happens in the converging lens. So A is the right option. Question number 19. A is the right option, sir. Okay, so here we have question number 20 on your screen. So in the question number 20, the diagram shows an object in front of a plane mirror at which label position is the image of the object formed. You see, this is always done. Do it with, if you have a hard copy of this paper, please do it with the help of so we start a ray from the object. It goes perpendicular to the mirror. It strikes the mirror, reflects back. I prolong that line behind. Okay. So join this with the point D. And from the D, I will draw here a normal. I will check the angle of incidence. I will draw the same angle of reflection. This angle of incidence and this angle of reflection, they both will be equals to each other. If you prolong this line behind the mirror, so this reflected ray, when you prolong it behind the mirror and you prolong it behind the mirror, this reflected ray where they intersect each other, there the image is seen by the observer. So I think at the B, the image will be seen. So question number 20B is the right answer, sir. Question number 21. The diagram shows the action of a thin converging lens on the two rays of light. The rays are from the top of an object and inverted image I is formed. Which name is given to the distance RS? You know, this ray, which was parallel to the principal axis, after passing through the converging lens, passes through this point S on the principal axis. This point F is called principal focus. This point F is called principal focus. This is called the principal focus. And this line, which is starting from the head of the object, passes through the optical center. This point is the optical center of the lens. So it do not deviate. Okay. So the distance between the optical center and the principal focus is called focal length. So that distance is called focal length. So the distance RS is called focal length. It's a fact. Question number 21, C part. Yes, that's the right answer, sir. Okay, so we have question number 22. So here we have question number, sorry. We have question number 22 and, okay. He says the diagram shows the air molecules in part of a sound wave at a particular moment in the time. Which statement is not correct? So we are looking for that statement which is not correct. Okay. So here you have that point X. The wave is most probably going in that direction. So this point is right now in the center of a rarefaction. Earlier there was a compression at the X, that is possible. Yeah. And later there will be a rarefaction at the X. Here right now we have a rarefaction, and after some time again a compression will come, then a rarefaction will again come here. That is true. This part of the wave is traveling horizontally across the page. Yes, this particle, because of sorry, because this is going in the direction. Okay, so because the wave is going in this direction, so what will happen? This particle, because this is a longitudinal wave, so this particle vibrate about its mean position parallel to the direction of the wave. So this will be going in this way about its mean position and going in this way. It is vibrating basically about its mean position. So it's this is the particle of the medium. It's vibrating parallel to the direction of the wave. That's longitudinal wave. So C is not, C is also the right, not the right answer, sir. Okay, then we have the D part. He says this part of the wave is traveling towards the top of the page. This particle is not going to the top and the bottom. This is not vibrating perpendicular to the direction of the wave. That do not happen in the longitudinal wave. So this statement is actually wrong. So I think D is the, we were looking for that statement which was wrong. So D is wrong. Question number 22, D is wrong. Yes. So our answer is right. Then we have question number 23. He says the speed of light in a vacuum is 3 × 8 meters per second. Which value is closest to the speed of light in air? The speed of light in air is almost the same. So that is D choice. It's a fact. Question number 22, D is the right answer. Question number 23, D is the right answer, sir. Question number 23, D is the right answer. So here we have question number 24. Here he says, a 100-meter race is started by firing a gun. The gun makes a bang and a puff of smoke at the same time. When does the finishing judge see the smoke and when does he hear the bang? You see, he will see the smoke immediately because the light travels very fast. Okay, so he will see the smoke immediately because the light travels very fast. About the sound, the distance between the gun and the finishing judge is 100 meter. So the sound speed is almost like 320 meter per second, or you can say 300 meter per second, or 330 meter per second. So almost 300 meter per second in the air. So divide that distance with that speed, you will get the how much time it will take to reach him. So let me show you. So question number 24, distance traveled divided by the speed, that is 100 meter divided by 300 meter per second, so 0.3 second. So the sound will reach him 0.3 seconds after. So the smoke he will see immediately, and 0.3 seconds after the gun is fired, he will hear the bang. So question number 24, B is the answer. Yes. So we have question number 25. He says a student is to demagnetize a bar magnet. She tries 4 different ways. Hammering the magnet. Yes, it demagnetizes it. Heating the magnet. It demagnetizes it. Passing direct current through the magnet. No. We pass alternating current, then it demagnetizes. Placing the magnet in the water. It does not affect. Which methods will demagnetize the magnet? 1 and 2 only. 1 and 2. Question number 25. B is the answer, sir. Famous facts. A student, question number 26. A student is investigating a resistance wire. She measures the current in a 50 centimeter length of resistance wire. The student repeats the experiment using a 100 centimeter length of the same resistance wire. What is the effect of this change on the current in the circuit and on the resistance of the wire? You see, instead of using 50 centimeter, if you will use 100 centimeter, you have doubled the length, so the resistance will also increase. The resistance will also become double. The resistance will increase. So when the resistance of the circuit increases, the current coming from the battery decreases. So the current will decrease and the resistance of that wire will increase, decrease, increase. So I think B is the answer. Question number 26. B is the right answer, sir. Question number 27. A resistor is connected to a cell so that there is a current from positive terminal of the cell to the negative terminal. What causes the current in the resistor? Electron moving from the negative terminal of the cell to the positive terminal. That is true. The current is due to the flow of the electrons. Electron moving from the positive terminal of the cell to the negative terminal of the cell. That is wrong. Protons move. Protons do not move. The protons do not move in the electric circuit. CD is wrong. Question number 27. A is the right choice. Question number 28. He says, in the question number 28, he says, a plastic rod is rubbed with a dry woolen cloth. The rod becomes positively charged. So the rod becomes positively charged. Which statement is correct? Because the rod has become positively charged, so it has lost electrons. It has lost electrons. So electrons move from the cloth to the rod. No, electrons move from the rod to cloth because the rod became positive. So it has lost electrons. Protons move, protons do not move. Okay. Question number 28, B is the right answer, sir. Means protons do not move in that circuit. Okay. Which question number 29, which combination of the current in a resistor and the time for which it is present results in a charge of 240 coulomb passing through the resistor? Okay. A current of 2 ampere for 120 seconds, a current of 4 ampere for 960 seconds, a current of 6 ampere for 40 minutes, and a current of 8 ampere for 30 minutes. You know, I is equals to Q divided by T. Q means charge. So Q will be equals to I multiply T. So we will have here 2 amperes multiply 120 seconds. That will be 240 coulomb. This is the answer. Okay. This is the answer, sir. This is the answer. He asked us to find in which situation is the charge to in the very first situation. Okay, Q2 you can find 4 multiplied 960, that is 3,840 coulomb, and Q3 is 6 multiplied 40 multiplied 60 because the time must be taken in seconds. So that will be 14,400 coulomb, and the Q4 that will be 8 multiplied 30 multiplied 60 because I've converted 30 minutes into seconds. So 14400 coulomb. So A is the answer, sir. A is the answer. So I think in this situation, the charge is 240 coulomb. So question number 29, A is the answer, sir. Question number 29. Question number 29, A is the answer. Okay. Question number 30. Each potential divider is placed in a circuit with the power supply. Which potential dividers makes the potential difference across the component by increase when the light intensity increases? So they are talking about light intensity. Light intensity affects only the LDR, light dependent resistor. So the option is either A or B because they have the LDRs in them. So when the light will increase, the resistance of this LDR will decrease. So whatever is the voltage given in this circuit, this will start taking less voltage. So obviously the voltage drop on the wire will increase. So this is the choice. Question number 30A is the choice, sir. This is the potential divider, LDR, and fixed resistor. If the resistance is less, the potential difference, potential drop across that resistor is also less. And if the resistance is higher, the potential drop across that is also higher. Okay, two resistors R1 and R2 are connected in series in a circuit as shown. The current in the resistor is I naught. He says another resistor R3 is then connected in parallel with the R2 as shown. So the current coming from the battery is now I1, and the current flowing through this branch is I2. So basically what will happen, their question is, okay, so how do the currents I1 and I2 in the resistor R1 and R2 compares to the I naught? You know, in the I naught will, there are two resistors in series. So the I naught will be smaller because when the resistance of the circuit is higher, the current coming from battery is less. Here you see what you have done. You have connected these two resistors in parallel to each other. So the resistance of this circuit is less than the resistance of this circuit. So this I1 will be greater than the I naught. Okay. So either the C or the D is the right option, sir. This I2 here, you know, the I1 current is divided further. So this I2 current cannot be, we are not sure if this is equals to the I naught, but it is less than, definitely, than I naught. So you see, here we have, sorry. Here we have competition between these two, but I naught, I'm not, you see, before the current flowing through R2 was I naught, but now we have a parallel resistor to R2, so the current flowing through R2 right now cannot be I naught. So it should be less, I think, than the I naught. It cannot be equals, I think. So I think D is the option, sir. This is a very tricky choice. D, I think D is the option. Question number, this is which question? This is question number 31. Let's check. Question number 31. D is the right option, sir. This is a very, very tricky choice. Okay. So for sure, I2 is less than I naught. So because the current has divided. The diagram shows a circuit containing a cell, a lamp, and two ammeters. So their question is, sorry, the current reading on the ammeter 2 is 0.20 ampere. What is the name of this type of circuit and what is the reading on the ammeter? They all are connected in series with each other. This is showing you the current coming from the battery, and this is showing you the current going back to the battery. This is the rule that the current coming out of the battery is equals to the current going back to the battery. So the ammeter number 1 will also show 0.20 ampere. So it's a series circuit, and the reading on the ammeter 1 will be also 0.20 ampere. So I think A is the choice. Question number 32, A is the choice. Question number 31 was a difficult choice. I hope you are able to understand it. Okay, question number 33. It's again a difficult question. Question number 33 is about basic electronics. The diagram shows how logic gates can be used to monitor the temperature in a refrigerator. Okay, so here we have an input, which is the magnetic switch on the door. If the door is closed, it means 1. When the door is open, it means 0. Temperature sensor, when it is cold, it means 1. When it is hot, it means 0. Here we have NOT gate. NOT gate will change whatever is the input here. The opposite will be the here. So W will be opposite to the R. X will be always opposite to whatever is the S. This is an OR gate. OR gate means like adding up. And so whatever is there at addition, so that is the output. That output is given to this AND gate. This is the Y input. Here another input is coming from T, which is the main system switch. And when it is on, that means 1. When it is off, that means 0. So then AND gate's output is Z, which is given to a warning light. They say the AND gate means multiply, okay, in the Boolean algebra. The warning light will come on if the output at the Z is 1. If you will have here 1, this will give out light. This will give out light. It will start giving out light. Okay. So he says the warning light will come on if the output at the Z is 1. The door R is open. The door R is open. When it is open, it is 0. So here you will have 1 because it will be opposite to this. And the temperature sensor RS is cold. When this is cold, that means 1. So the input here will be 0. So when you add them, the answer is 1. So the Y is 1. And the main switch T is on. So this is on. So here you will have 1. So it's like multiplication, you will have 1 and it will light. Okay. What is the logic state of Y and what is the state of the warning light? So when Y will be 1 and the light will lit. So 1 and the light will be on. So I think D is the option. Question number 33. D is the right option, sir. So here I have tried to show you. Okay, I have tried to make that truth table. So here you can see I have made the truth table for R and S, W and X. W is opposite to the R, X is opposite to the S. And then there you have OR gate. W next is fed to the OR gate. And there the output of the OR gate is Y. And in the Boolean algebra, Y means W plus X. So I have made that truth table. And Y and T is the input to the AND gate, and the output is Z, which is fed into the light. And I made that table. So he says the door is open, the temperature is cold. So the Y will become 1. That is the question. When the Y is 1 and the main switch is on, the Z will be 1. When the Z is 1, the light will be on. So that is, I hope you understand, you know how to make these truth tables. This topic is no more in our Cambridge O-level syllabus. So D is the choice, sir. Question number 33, D is the choice. Okay. 33, D is the choice. Okay. So here we have question number 34. He says 4 small compasses are placed around a solenoid. A current is now switched on in the solenoid. Which diagram shows possible new directions of the compass needles? Okay. So you see here the magnetic lines are entering. Here also the magnetic lines are entering, which is not possible. Where the magnetic lines are entering into the solenoid, that is the south pole. And it has south pole on both the sides. This is wrong. Here the magnetic lines are coming out. Here the magnetic lines are entering. Okay, that can be possible. So this will be your north and this will be your south. Then the magnetic lines from north, they will go like this. So this magnetic compass is not showing the right direction. This magnetic compass is also not showing the right direction. So this is not possible. This is wrong. This is also wrong. Okay, if you look at the C, the magnetic lines are coming out from this end. So this is your probably the north. And this is your south. From the north, the magnetic lines will be going in this direction. So this is not right. From here, they will go like this. So this one is right, but this is not right. So this part cannot be the answer. Okay, look at here. This is the south. Okay, from here the magnetic lines are coming out. So this is the north of the solenoid of this electromagnet. So from here the magnetic lines will go this way, north to south. So this magnetic compass is showing right direction, and here they will go like this. This magnetic compass is also showing the right direction. Its pointer is pointing in the right direction. So I think D is the right answer, sir. Question number 34. D is the right option, sir. Question number 34, D is the right option. I hope you understand how we have done this. We are on the question number 35. Which metal is used for the core of the transformer? The core of the transformer is always made with the soft magnetic material, and we use soft iron for this, which is easy to magnetize, easy to demagnetize, especially easy to demagnetize. Soft iron. Question number 35. C is the answer, sir. Yes, that's true. Question number 36. The diagram shows a conducting metal rod PQ in the magnetic field between the North Pole and the South Pole. The rod is connected to a resistor in a circuit. In which direction should the rod PQ be moved to induce the current I in the direction of the arrow in the circuit? You see, that conductor must move perpendicular to the magnetic field. And when it moves perpendicular to the magnetic field, it cuts the magnetic lines and the EMF is induced in it. Okay, he has shown us the direction of the current. Okay, so I can apply the right hand rule. You see, when the current is induced, we use right hand rule. So right hand rule, stretch these three fingers perpendicular to each other. They are mutually perpendicular to each other. The thumb, the index finger, and the middle finger, FMC. So this is the force in which the direction the coil will be moved. M means the magnetic field, which is the forefinger, and this middle finger is showing the direction of the conventional current. Because if I apply here, the conventional current is going in this direction, the magnetic line is coming in this way. So I have to twist my arm. Okay. So magnetic field is going from north to south. Current is going from P to Q. Then my thumb is pointing upward. So that means you have to move that in the upward direction. You see, one method is that very easy, that you move perpendicular to the magnetic lines and the EMF will be induced in that conductor. And another method is use the right hand rule for the generator. So, and then you can tell in which direction the coil will move, that conductor will move to induce current in that particular direction. So you should understand how to use the right hand rule for the generator. Okay, question number 36. We think A is the choice. Question number 36, A is the right choice, sir. Question number 37. A thin metal foil is placed in a vacuum. Alpha particles are fired at the foil and most go straight through. A very small proportion of the alpha particles are deflected through page angles. What does this provide evidence for? That means that there is a very small nucleus. Most of the space in the atom is empty. Alpha particles are very small. No, there are negative electrons in each atom. No, there is a tiny nucleus in each atom. This is what they prove. There are neutrons in each atom. This experiment do not prove this. This expression tells us that there is a small nucleus in the atom. C is the choice. Yes, sir. Most of the atom is empty space. Question number 38. The table compares alpha radiation, beta radiation, and gamma radiation. Which row is correct? You know, the gamma is the most ionizing. It's more ionizing than the beta and the, sorry, I said gamma. Sorry. Alpha is the most ionizing, alpha particle, which is like the helium nucleus. So alpha radiation is most ionizing. It's more ionizing than the beta or the gamma. Beta is an electron, and the gamma radiation is electromagnetic. So alpha is more ionizing than the beta and the gamma. Beta radiation is electron, and the gamma radiation is electromagnetic radiation. So C is the choice. Question number 38. C is the right choice. Question number 39. A high voltage power supply is connected to a metal grid and a wire as shown. They are not connected with each other. There's a gap between them. So if the air here, if it gets ionized, then you will see these sparks. When radioactive source is placed close to the grid, sparks are observed in the position indicated. Which statement explains why are the sparks there formed? You see, here we have a strong voltage difference between these two, this wire and this metal grid. Due to this source, which is emitting alpha particles, this air here, it will get ionized. When this air get ionized, the path of this current will be completely due to those ions, and you will see these sparks. Alpha particles have a long range. No, alpha particles range is very small. Alpha particles have no charge. That's not true. Alpha particles has positive 2 charge on them. Alpha particles have no mass. No, they are like the nucleus of helium. Alpha particles are strongly ionizing. Yes, they ionize the air there. So I think D is the choice. Question number 39. D is the choice, sir. So we have question number 40 coming up on your screen. Here we have. A student investigates 4 different radioactive isotopes. The student places a detector near each radioactive material. The background count rate is 36. So this is the background count rate per minute throughout the investigation. The table shows the detector's readings at the start and after the 8 hours. Which isotope has a half-life of 4 hours? If something has half-life of 4 hours, then in 8 hours, 2 half-lives will pass by. So how many half-lives have passed? Two half-lives would have passed. Okay. So in the 2 half-lives, you know how much is left of the original? How much is left of the original? After 1 half-life, the thing becomes 1 by 2, and after 2 half-lives, the thing becomes 1 by 4. So let me show you my solution. Here they have given you count rate at the start and the count rate after 8 hours. Okay, if the half-life is 4 hours, what will happen? You see, if the half-life there is 4 hours, then after 8 hours means 2 half-lives have passed. So if the first sample at the start has a reading of 150, so from that subtract the background, you are left with 114. So divide 114 with the 2 square if 2 half-lives have passed. So now the remaining original sample will be, the remaining will have the count rate of 1 by 4th. So 114 divided by 4, that's 28.5. And so add back the background in it. So 28.5 plus 36, this is 64.5. So their reading is 36, so which is not matching this. So that cannot be the answer. In the B, the count rate is at the start, the count rate is, let me show you, is 212, and then it's 53. Okay. So 212 minus 36, so 176. So 176 divided by 4, that is 44. Add back the radiation, background radiation. 44 plus 36, the reading will be 80. But they say after 8 hours, the reading is 53. So this is not the choice. Okay, C option. At the start, the reading is 260. From 260, subtract the background. So 260 by 36, so you are left 224. After 2 half-lives, the reading will become 1 by 4. So 224 divided by 4, that is 56. and again add in it the background. So you will have 56 plus 36, that will be 92. 92. And this is the option. This is this is something whose after two half-lives, this will be the reading. So I think C is the choice. Let me show you for the last one. It says for the D part, 356 minus 36, this is 320. And 326 after two half-lives would have become 80. And 80 plus, again, add the background, 116. But they said that the reading is 80. So it's not the answer. So C is the answer, sir. It's a little tricky question. C is the right answer, sir. And this is how this is done. I hope. This is how this is solved. You see the reading of the machine. From that, you subtract the background because they are saying two half-lives have passed. So you divide that count rate with the 4. And whatever the answer you get, you again add the background in it. So that will be the reading on the machine, the detector. And we check if they have given this answer, if they have got different answer. So this is not that sample whose half-life is 4 hours. So C is the option, sir. So C is the option. Our answer is right, sir. Okay, so my dear students, we have completed this paper. So now you see what happened. We have completed the 40 questions in this video. We have presented you the solution of this paper. I've tried my best to explain you, to describe you, to write the answers in such a way that you can understand. But still, I am a human being. I might make a mistake. So please forgive that. If you think this video is beneficial, if you think this video is useful, and you think this video can help your friends, your class fellows, your junior students, your teachers, please share the link of this video with all of them. Share the link of this video on your WhatsApp groups, on your Facebook, on your Twitter, on your Instagram, on your Snapchat, on your TikTok. When you do this, you help me, you support me. And that support is very, very important. So whenever you watch this video, any video on my YouTube channel, please like this video. Today, I will request you that if you are watching my video, please in the comments write that you are watching this video from which city and from which country, because that's I feel blessed when I see so many people around the globe watching those videos. So have a good day, sir. Thank you very much. Keep working hard, and God may bless all of you.